Hi, and welcome to our third part of Topic 3, Water. For this last little bit, we're going to be going over water pollution, the difference between point sources and non-point sources, and looking at some common contaminants. So, water pollution can come from one of two locations, a point or a non-point source. A point source is a discharge of pollution from a specific location. So you can go out to a field and go, this is where the pollution is coming in from. An example of that would be a drain pipe, a ditch, sewers, anything that you can go back and reasonably say that this is where the pollution is happening. A non-point source is the flip side. So there's no specific location. You can't go out and say, well, this particular pipe on this particular farm in this particular county is impacting this water. So runoff from farms, which you can see over here. This runoff could be coming from anywhere in this field or the adjacent fields. You can't necessarily go in here and point the blame. Golf courses are a non-point source. Lawns, your own lawn. Construction site, logging, mines, roads, and parking lots. So unfortunately, the bigger sources of pollution are non-point source, which makes them harder to nail down and harder to clean up because it's hard to figure out who is responsible. There are biological pollutions, which include both waste and pathogens, so diseases. These are the most serious of the contaminants. These are the ones that are going to make you sick. They will have an impact on human health. You can get typhoid, cholera, dysentery. So if you ever played Oregon Trail, you died of dysentery. That comes from drinking dirty water. Enteritis, polio can also come from biological pollution in water. Hepatitis, and schistomiasis. Sorry, that one's a hard one for me to say. But all of these can come from having contaminated water. These are deadly. They are still killing people globally. Typhoid, cholera, and dysentery are three of the biggest diseases that end up killing people across the globe. If there's any coliform bacteria in a water sample, it's likely that there's an infection. So you have to test water for these sorts of biological pollution in order to determine if they are going to be safe for general consumption. There are also inorganic pollutants, which are metals, and these can be your heavy metals like lead, salts, and acids. So this is why the salmon is here. Another heavy metal is mercury. Mercury poisoning is a very big one. You have to be very careful how much fish you eat, what kinds of fish you eat, because some fish contain high levels of mercury due to contamination within the water. Typically, the higher up you get in the fish food chain, the more mercury accumulates. So you need to watch out for some sorts of fish because they can be harmful, especially for pregnant women and children. In addition to these two, there are also organic chemicals, which include pesticides and other industrial substances. You see in the picture here, this household, they are washing in here. These are going to be industrial substances such as detergents. You can have different pesticides that are going to be running off from this area, or insecticides, trying to keep the bugs down, running straight into this polluted waterway. There are two principal sources for toxic organic chemicals in your water. And these are improper disposal of industrial and household wastes. So what do you do with batteries when you're done with them? We all just toss them in the trash can. But where does that go? Eventually that could get into the water supply. Or what happens if you run out, there's just a little bit of bleach left in the bottle, but not enough to use, but too much to throw away, pour it down the drain. Or if you spill oil outside, say you're changing the oil in your car and you spill the oil. So there's a lot of different ways that we impact the water just by ourselves. Pesticide runoff is the second principal source from farm fields. You don't want to have things eating your crops. You want to be able to have as much profit as you can, so use pesticides. Forests, same thing. There's right now, across the country, there's an issue with the emerald ash borer, which is a beetle. And it kills ash trees, and it's spreading across the country, and so we use pesticides to try to stop its movement so we don't lose all of the ash trees on our continent. Roadsides, we use pesticides to keep away bugs and other harmful insects from the roads, or golf courses. You don't want to have a bunch of mosquitoes on your golf course, and your private lawns. There's a big business all over the country of spraying lawns with pesticides to try to keep ticks and fleas and lice and all those other critters that are harmful to humans off of our lawns. All of those chemicals soak in and go into the water. It's important to watch how many nutrients are going into your soil or into the water because of the concept of eutrophication. Now, rivers and lakes that have clear water with low biological productivity, so the water is perfectly clear, but you don't see a lot of necessarily plants underneath there, not a lot of fish. These are called oligotrophic. Oligo means little, and trophic means nutrition. The flip side of this is a eutrophic waterway. So you have trophic, or eu means well, and then trophic still means nourished. So this is a well-nourished water. They're rich in organisms and organic material. Now, this means too much. They have nutrient overload. So remember last summer into the fall when we had the problem with the red tide, which went around causing those algal blooms throughout the coast, up Lake Okeechobee. These were killing off the manatees, sea turtles, and thousands of fish. This was eutrophication. This was a nutrient overload where the water could not handle the amount of nutrients in there and created these algae blooms that choked everything else out. So eutrophication can be very dangerous. So this is an important figure. You can see on the top we have our types of organisms. Below that in blue, dissolved oxygen. So how much oxygen is in the water in ppm, which means parts per million. Underneath that is the biochemical oxygen demand. So we have our point source pollutant, our pipe that's chugging black sludge, brown sludge into the water here. So we have a clean zone upstream where we have normal clean water organisms, which include trout, perch, bass, mayflies, and stoneflies. This is called the clean zone. Everything's hanging out, having a great time. Now, the dissolved oxygen starts to decrease as you reach the point source. The biochemical oxygen demand, BOD, rises sharply. Once you reach this next zone, which is called the decomposition zone, you have pollution-tolerant fishes, such as carp and gar. If you look in a lot of your canals around here, you'll see alligator gar, and because our canals aren't necessarily the greatest water. Now, all of our water is going to start flowing towards the right-hand side of the screen. So the next zone after decomposition is the septic zone. This is the lowest point of dissolved oxygen. So we peaked at BOD here when we reached the decomposition zone, and we're going to basically level back out to where it was before. So here our BOD is decreasing. So we have fish, no fish, gone. All we have here are fungi, so mushrooms, sludge, worms, and bacteria. The bacteria have to be anaerobic, so they can actually work without oxygen because the dissolved oxygen content is so low. Some of the organisms here can actually live without oxygen. So this area is basically a dead zone. There's not much going on here. It is the worst part of it. Now, as we reach the recovery zone, the dissolved oxygen is going to start to increase. The BOD is going to continue to decrease until it's back to its original zone, our original levels. This area, we're back to our pollution-tolerant area, our fish. We have carp and gar back. And then as we get back into the clean zone, our normal fish will start to return, and our dissolved oxygen gets back to 8 ppm. Our BOD is back to its original level. So you can see the part where the point source is polluting, that's not actually the worst zone. It's downstream from that where you see the most damaging effects. And then as the water dissolves, because remember H2O is considered the universal solvent, you get this recovery back to normal. Now, depending on how big your point source or non-point source is, these three zones of decomp, septic, and recovery can be much bigger. So this is just a nice simplistic model of how this works. Pardon me, I gotta take a drink really quick. Okay, now, water use in the world is at an all-time high. We need to use our water more sustainably. It is absolutely imperative because, like I said, there are cities that are running out of water. Each of us can help bring about such a quote-unquote blue revolution by using less water and wasting less water. So, one of the things you can do is, well, obviously here's sustainable water use. Use less water, substitutes water conservation. But things that you can do as a person. If you have the option between a bleached and an unbleached product like coffee filters, get the unbleached. It takes less water to make unbleached coffee filters because paper's naturally brown. It doesn't have to be white. So unbleached materials are much better. The amount of water, if you're really going big, a bidet is actually more efficient water usage wise than toilet paper because the amount of water it goes into producing and bleaching toilet paper is far greater than the little bidet attachment on a toilet. You can also make sure that when you if you have sprinklers, you only use them when you need them, and you use them during the early morning or the early evening. There are times of day when the sprinklers are more effective. If you water your lawn in the middle of the day, you are wasting water and your money because you're paying for that water. There's a thing called capillary fringe. And so the soil itself is actually more open to receiving water in the early morning, like as the sun is rising, or in the evening as the sun is setting. And as a global community, we need to work to not deplete our aquifers, which is easier said than done because a lot of our food production requires using the aquifers. Obviously, preserve water quality, which again will require lots and lots of work because it's already pretty messed up. We need to be aware of protecting our forests, wetlands, mountains, glaciers, watersheds, and other systems. But all of these things over here in this box are going to take radical change on an international government level. So it's more important to, like obviously if we can enact change, we need to enact change. But there are also things that you can do that I just mentioned. So with that, we are going to close now. Just a reminder, at the end of each of your lectures, there are sample questions. Please go through these sample questions. Go back through the PowerPoints. The non-narrated PowerPoints that you can just look through are available for you on D2L. If you do have any questions about what answers are correct or incorrect, you can ask me during class the next time we meet. I'm always happy to answer those. So please look these over, and I will see you guys in class.